That's it from my side. Jamie, over to you.
Great, thank you. Hi, everyone. My name is Jamie Danielson. I'm a software engineer at Honeycomb, and I primarily work on writing instrumentation libraries to help you instrument your software. And that's what I'm going to talk to you about today. So I'm going to start out with sharing my presentation here. And as mentioned before, we are leveling up our observability with OpenTelemetry. We have quite an ambitious agenda today, so I'll try to get through all of it, and hopefully some of it is at least interesting and gives you something to take back to your teams. We're going to start out with looking at what is OpenTelemetry. We'll talk about and actually do some hands-on coding for instrumenting your systems. And then after that, we'll talk about how you can roll it out in your organization. So the first big part is, what is OpenTelemetry? But first, what's observability? We may have heard that observability enables predictability, quality, resilience, user insights, but what does that actually mean when it comes down to it? It means that we can ask questions about our systems, about our software, without knowing the details of its inner workings. It helps us answer the question, why is this happening? We might know that our app is slow. Users may be reporting that something is slow, but we could have 100 different services that are causing the problem. So how do we know where that problem actually is? As time goes on, you may notice that we've been moving away from monolithic architectures to microservices. And what that means is we generally start with, in the past, we had sort of everything in one place. So you can sort of follow the flow from start to finish of how a user may make it through your application. But today we have microservices, meaning that things are split up, and it becomes a lot harder to track those users from service to service to service and know what's going on. So one of the important things with observability is called context propagation. And essentially what that allows you to do is to follow that request from service to service because it's not all in one place. It involves injecting values into your downstream service and taking them out so that you can link those services together when we get into what's called distributed tracing. We're going to be starting with a simple kind of silly app just to sort of visualize what's going on here. We have this app that's called Deep Thought. You enter in as a user through the gateway service, then there's a question service, and there's an answer service. What we can find with the service, so actually here, if I were to just hit the service, all it does is a very simple thing, is I hit that endpoint and it says, what is the answer to the ultimate question of life, the universe, and everything? 42. What you may have noticed is that was a little bit slower than I really expected it to be. As we said, it's kind of a simple app, but why is it so slow? And we might know whether from a user telling us or from a log somewhere saying that it took 2 seconds from start to finish. But what we don't know is what part of that service was slow. Was it the gateway service, the question, the answer service? We want to go from, we know that it was 2 seconds start to finish to, in this scenario, the slow part was in the answer service. The question service was actually very fast. And this is what observability is going to let us do, is it's going to help us narrow down where our problems may be and where we need to focus our attention. So what's OpenTelemetry then? Well, OpenTelemetry is a standardized open source and vendor neutral way of generating, collecting, and exporting telemetry data. So we use OpenTelemetry as this format for observability. So we have our application, we have OpenTelemetry, which is where we instrument our code, and then we have a backend where we can see where things are slow. This might be Jaeger, might be Honeycomb, it might be Zipkin, it might be Lightstep. Several years ago, it was kind of known that we needed to have observability and we needed to have these different standards because at the time there was open census and open tracing. Those were both very popular, but they were different. And so they actually merged together to form OpenTelemetry. And OpenTelemetry now has a specification and has semantic conventions, which lets us more guarantee consistency across languages and implementations. So you shouldn't have big surprises as you go into different languages or different applications. OpenTelemetry is actually the second most active CNCF project. So that's cloud, the Cloud Computing Foundation. Sorry about that. Here you go. And so one of the other CNCF projects that you may be aware of is Kubernetes. Kubernetes is number one. So being right behind Kubernetes is kind of a big deal. Now with OpenTelemetry, it's vendor neutral and it's open source. So you have contributions from vendors, community members, hobbyists. You have different languages and libraries that are available to you. And it reduces the need for vendor-specific SDKs. So what some people may have experienced is this specific vendor says, here, use my agent, add it to your application, and you can start seeing what's going on in your system. But then when you want to switch to something else, maybe you're not happy with that, or it's not quite getting you what you need. It's very painful. You have to rip out all this code. You have to do something totally new. The idea of OpenTelemetry is that this is something that all of these vendors can use as long as they support this open standard. And more vendors are doing that. This allows them to compete on the quality of their products, not how hard it is to actually instrument your software. And so what we're going to talk about now is how to actually do that, how to get from, I know this took 2 seconds, to I know that the answer service specifically is slow. And we're going to get into some details here about OpenTelemetry. So we start with our service that we talked about before. And what we're going to add in here is OpenTelemetry and this thing called the collector, which we'll talk about a little bit. And the collector, basically what it lets you do is you take your telemetry data, send it to one central place, and that can now send to different places. From a high level, what we generally want to do is we want to have our more automatic instrumentation. So it's a little bit less hands-on code, just kind of getting started quickly. And then over time, we can add manual instrumentation. So when we find where we have gaps or where we're not seeing the details that we need, that's where we would add in manual instrumentation. The TLDR of that is start small and start with places that have big impact. You don't want to get overwhelmed as you're going through this new process. So what's needed for tracing? I'm going to throw a glossary of words at you for a moment, but hopefully this will make sense as we go through it. We start with having our resource, which is what describes where the span is coming from. In our service, our gateway service has a service name, gateway service. That's generally what our resource is about, is where is that span coming from? Then we have a tracer provider, which is how our span should be generated. It's the entry point of the API and lets you get access to those tracers to trace through your code. A processor explains what a processor does is it processes your span. So generally what you'll see is a batch span processor, which means that it's going to gather all of those spans in a batch and then send them off. Finally, here we have our exporter, which describes where the span goes. So we're going to export all that data that we just collected into a batch, and we're going to send it off somewhere. And finally, here we're going to mention propagation. So a propagator is what lets us say that this trace goes with, or this service goes with this service. So we can take details from service A, pass them down to service B, pass them down to service C, and then we can know that they are all interconnected instead of being separate services. We'll add in the OpenTelemetry collector here, because as I mentioned before, this lets us have these different services that are sending data, all send it to one place. So you can have this sitting in the middle of everything that comes in, and then have your collector send it off to different places. An example of a configuration is just receiving OTLP wire format, processing it as a batch, and exporting it. In this case, we're just going to export it to Honeycomb, but you could also be exporting it to Jaeger, to Lightstep, to those other backends that I mentioned before. But what this allows you to do is after you've instrumented your code with OpenTelemetry, you can change where that data goes without having to touch your code again, because we're just setting our endpoint here in the collector. Now, for some languages, we have things for automatic instrumentation that are a little bit smoother than others, like Java and Python. They have these nice agents that work. But for most of these other languages, we're going to we're going to have these instrumentation libraries that are available that you add in these imports, and it lets you wrap some popular packages. We're going to focus on this because we're going to work in Go today. And Go doesn't have one of those agents like Java or Python. I believe we'll be passing out these slides afterwards, so you can check out those links I had on there. But for something like this instrumentation library, basically, if you're using a relatively popular package, so in Go, if we're using the net HTTP package, there's an instrumentation library for it. So in this case, we just have a hello app, and we are wrapping it with this OTel HTTP instrumentation library. So what we can do then is we can see this in action. And now I'm going to switch over to actually looking at some code. Okay. So right now, if I'm looking at this app, I started out with my gateway service that, as you saw before, is relatively simple. It had a call to a question, to an answer, and I hit this endpoint to get a response. What I did was I created a copy of this service, of these services, to show this side by side. But generally, you would add this in as you're going or do this in your development environment. We're going to start out by importing some libraries, and these are available on the OpenTelemetry websites and in GitHub. And there are also going to be links to that in the presentation. But so we have some imports that we want to bring into our app. And then we have here, as I mentioned, that we are setting up with this function, a new trace exporter. So this is exporting the data out. We have a function for creating our new tracer provider, which is also going to use a batch span processor. We create that tracer provider, and we add in our propagation. So this is adding in W3C trace context and baggage propagation. And so what this then looks like is we can actually make a request again for our app. Again, we notice that it took a couple of seconds. But now that I've instrumented it, I can see a little bit more about what took so long. So right now, I can look at this trace. And now I can see not just that this took 2 seconds, but I can see when I open this up that the question service was quite quick, actually, but our answer service was really slow. And so this means now that we know where we want to focus our energies. We know where there's a problem and what we should be looking at. So let me move this window here out of the way. Okay. And so this becomes handy. Let's see here. This becomes handy because, again, we don't have to waste time. In our case, we're working with a very simple app. This is small. This is silly. This probably isn't representative of what you're working with. But even in this small, simple app, we have a way to narrow down. Imagine if we had 100 different services and are wondering what is slow, what's going on. So that's our version of automatic instrumentation for Go. We are able to use our libraries and our instrumentation here for that popular web package to trace that request going from service to service. Your next step now might be not just to look at your answer service, but to say that there's even more information that you think you can get out of this. There might be more interesting information inside each of those functions. And so what we want to look at then, sorry about that, what we want to look at then is where are those functions, and is there something else that we can add in here? And that's where manual instrumentation comes in. So we know that, I apologize, I'm missing my scroll bar. I'm trying not to make you dizzy as I scroll. So what we might decide to do then is add manual instrumentation. So for example, in our answer handler, in this case, we had something silly of time.sleep, but let's pretend that was an expensive computation. And maybe there was other information here that was interesting. What we can do here is we can take our tracer that's currently existing in our app, and we can start a new span. In this case, I decided to call it thinking about the answer. And here's where some interesting information is happening. I can do this in various places, and I can create new spans. Let me find an example here. I think I have one in my gateway service. Okay. So we're adding another manual span here and also question service. So similarly, we could have extra information in here and add more interesting information, including things like attributes. Attributes are where you can add individual fields that really describe what may be interesting about what's happening in here. Depending on your scenario, it might be something about maybe a user ID, or maybe some other calculation or product ID or other interesting information. You can then add that to the span that you're working with as a key value pair. And so now that we've added this in, I have this new app up and running. The app is working the same way, but I have some extra information there that might be interesting. Now, if I go back into my backend, in this case, I'm using Honeycomb, but it could be somewhere else. What you might be able to see here, although I think it's a little bit off screen, is that I have number of spans 9 here instead of 5. So this is similar to what we saw before, but each of these little stars are now our manual instrumentation that we've added in. So we can see that the amount of time that's spent here is roughly the same, but now we have more information that might help us. So for example, we can see that not only is that call to the answer service slow, looks like there's 2 parts to it. One part here is taking a full second and one part here is taking a full second. So again, we can now dig into those specific parts of our code and try to figure out what's so expensive and what's taking so long in that part of our code. And so as we see here, just a screenshot of already with our first set of automatic instrumentation with instrumenting with the library, we can see that the answer service is the slowest of the entire trace. And after we've added some manual instrumentation, we can see even more detail that breaks down even further what's happening in that app. So the next big thing that tends to come up is how to roll this out to your organization. People tend to talk about pushback that they might get back from others. And so they want to have talking points and ways to bring it up as something that's important. So first, we'll talk about how do you convince your team and other teams that are dubious to adding this instrumentation. You may have heard the saying that sometimes people throw code over the wall and no one really appreciates having to deal with that code that's been thrown over the wall. You wrote that code, now there's a problem and I have to try and figure out how to deal with that problem, but I don't know anything about it. And then you have the person who did write the code saying, well, I can't remember what I wrote a month ago. So this becomes valuable because you start adding bits and pieces of your code into your instrumentation. So even if I didn't know anything about the answer service before, I know that there's a problem in that answer service. And the more details I add there, the more knowledge I have without even having to look at the code to start. That helps us troubleshoot and talk to our team about where we need to spend some time. What also becomes helpful is instrumenting as you go. So as you're writing a new feature, right, and you're writing new code, it becomes a lot easier to add in those extra pieces that let you trace your code while your hands are already in that code. Some things are going to be a little bit harder if you have a feature you've already written a month ago and now you've moved on. You don't want to think about that anymore. It becomes harder to go back and remember what you were working on and instrument that. You're tending to start there for a lot of people if you don't have a chance to do it ahead of time. But it can still be something that as you go through and over time are updating your old code, as you write new features, you also keep instrumenting it. It becomes a new habit as you go, where you can send those traces off to a development environment. You might have a local Jaeger up and running, and you can then see, is it what you expect? Is it slower than it was before? Is it a lot slower? Is there a function in here that's not working the way that you expected it to? So that just becomes a new way of working with your code. Most people have heard of test-driven development and may actually do that in a day-to-day. So this is observability-driven development. As you make a change, check out what it looks like and see if there are changes that you need to make before you put out into production. The next step, maybe the scarier part, is trying to convince management. How do we spend time on this as part of our features? Well, one way to look at it is that we're spending a lot of time debugging our code, supporting our code. If you have less time debugging, you have more time writing features. So if you're instrumenting your code and having a better feel of what's going on, where it's going wrong, and you can address that earlier on and faster, you can now spend more of your time writing features, which is ultimately what we want. You'll also have higher reliability, which means happier customers. You're able to debug faster, get to the bottom of issues faster. So your customers are now happier because they're not dealing with problems. If they are dealing with problems, you're able to resolve them faster because you have more visibility into what's going on. And when it comes down to it, if you really think about it, you're going to spend that time either way. And time is money, as we know. So we either spend that time on debugging and support, and possibly dealing with customer churn, or we spend that time instrumenting our systems and get ahead of it. We want to have confidence in the code that we're shipping and confidence when it comes to a problem and we need to debug it. So the thing to keep in mind with all of this is to start small. This isn't something that you turn on overnight. It's not something you want to do all at once. Start with something small that ideally has a big impact. So what we showed was, let's get the automatic tracing of our HTTP requests. Start with that and see how it goes. Realize where your gaps are in what you're seeing. So I saw that my answer service was slow, but maybe that answer service is huge. And I need to have more manual instrumentation there to figure out, why is calculate answer specifically so slow? What is so slow about that computation? By adding the manual instrumentation in there, you can get more of the nitty-gritty details. And you just keep iterating. As you get more information, you continue to see, well, I'd like to know more about what happened in this service, in this request. Keep adding that instrumentation to get that data. And as I mentioned, OpenTelemetry is an open standard. It's open source. There's a lot of community members involved. But it's always good to have more and more people involved in understanding how it works, what's going on, and seeing where they can pitch in. So there's a Slack for CNCF, the Cloud Native Computing Foundation. There's a link in here that will be sent out with the slides. There are also these weekly meetings for special interest groups, or SIGs. So the idea is, if you're really into the JavaScript instrumentation, you're really into the Go SDK, you can attend these meetings that are on a calendar that are just open to anyone who's interested in attending. All of this code is on GitHub, so you can participate with code reviews and bug fixes and PRs. Again, open to the community and always welcoming of more community involvement here. And there's also documentation updates. It's something that we continue to work on every day to try and have as much there to make it as easy as possible to get started. But there's always gaps, and you usually see those gaps when you're first getting started. That's the best time to share. Here's where I think something can be improved to help it make sense for new folks like me. And finally, I added some additional resources at the end here for the doc site for seeing OpenTelemetry in practice. There's this demo GitHub repository, which is a microservices demo for an e-commerce application. There's this book, Cloud Native Observability with OpenTelemetry, that really helps you get started and understand what all these different pieces mean. And there's a link to the repo that I used for the application that we talked about. And the illustrations that you may have seen throughout are from this site, undra.co. Thank you very much.
Thank you so much, Jamie. Now I know how to properly stress OpenTelemetry, at least in the beginning that was wrong, but super insightful. Thank you so much. And we have a couple of questions already in our chat sections. Guys, please throw in your questions either in the Q&A section or just like post it for everyone. There is one operational one, so I'll just like keep it, answer it now. So who is that? I didn't see the name, but someone is asking where will the presentation be available? So we'll send over the webinar recording and slides with our follow-up tomorrow. So you'll have it in your inbox. Just check for it. But there are other questions, more technical, that Jamie will be happy to answer now. So the first one is the span sum isn't 2 seconds. I guess it was when you were showing code during your presentation. I don't know if you need more context to answer this question, but yeah, that was the question.
Sorry, can you ask that one more time?
Yeah, so person asks, the span sum isn't 2 seconds.
So there was, and I apologize if there's any incontinuity between 2 different versions of the app, but there's at least one of the version there that was shown that was 2 seconds in total that ended up having 1 second on an answer handler and 1 second on actually calculating an answer. And so if there are gaps in what we saw there, that's our gaps that need to be filled with manual instrumentation, where we can see here's a total of 2 seconds. Here's what took up 1 second, but what took up that first second. And that's where we can add more manual instrumentation to say, we got the second part of that. We got the second part of that instrumented to know that that took a second, but we might need to add more in to see where did that first second come from. Does that answer that question?
I think it does. I would not be able to guess out of the context, but thank you for like remembering it. The second question is it a good pattern to write automated tests which evaluate OTel payloads, traces, spans after certain operations?
I guess maybe the reason for that question is wondering, I'm trying to understand why you would write a test specifically for that OTel payload, if it's maybe to see if everything that you expected to come through, everything that you expected to get exported went through. One option that I think all of the languages have enabled and the collector have enabled is the ability to export to the console. So you can see everything that's coming out there. Another option, if you're looking at maybe benchmarking, a lot of the languages have benchmarking for maybe the size of OpenTelemetry and what that's adding to your app. I'm not sure if that's the specific question, or thirdly, if it's what are we getting after this operation? You might not have a test specifically for, is this getting traced? You might actually use a development environment for that. So you add in a new feature, you've instrumented that new feature, send it to a development environment, either locally to a Jaeger or something, or export to a development environment, Lightstep or Honeycomb, and see from there, does it look the way that you expected to? That way you can see it in development, make more changes as you need to, and then when it pushes to prod, have that then send to your prod environment.
Thank you. The next question is, how is collector not a single point of failure in backend? If it's off, are traces missed or just suspended? Can they resume tracer provider downloads?
Yeah, that's a great question. And so I didn't dive into a lot of the details of the possibilities with the collector. If you have one single collector in that example, as I had, that's probably not an ideal scenario if you can help it for exactly that reason. If that goes down, your telemetry data is now hitting something that can't do anything with it. There are different options that you might have. So you can run, and I think one of the links is in the presentation to check out afterwards, but you could, for example, have collector agents which go alongside each of your applications. So you could have a collector running with your gateway and your answer and your question that each either send off to Honeycomb or Jaeger or whatever, or they can also send to another collector. You can also have, different collectors. If you're working in Kubernetes, you can have different collectors that are set up, and you can have your failovers as well to have it go to a different replica if you need to.
Got it. Not only questions, you got compliments, Jamie. That was one of the best professional presentations I've seen in years.
Thank you.
So the next question, do you have stack trace capabilities to kind of profiling the methods, functions of your instrumented code?
If we're talking specifically profiling, there's not something directly in here right now. I believe there are some open proposals into like the Go SDK. There's now like an automatic Go instrumentations SIG and repo that is looking at adopting a proposal for adding profiling for eBPF. And then there's also the option of using something like Pyroscope that helps you profile your code as well. But that's going to be a little bit different. OpenTelemetry is focusing on those traces, whereas profiling is going to be a little bit different. You can still use them both together, but it's a little bit different from what I was just going through.
Got it. The next question, any info on the overhead that the instrumentation adds to typical apps stacks?
Right. Generally, there's not very much. Most of the SDKs do have benchmarking along with the collector, usually have benchmarking tests available to show what the difference is between the two. The two things that I typically say to keep in mind is that one, a lot of this is running asynchronously, or it's being pushed off to the side instead of going through your code. And so by running asynchronously, it's not blocking your thread of execution. And then the other thing to keep in mind is of the amount of extra processing that may end up being in there ends up working itself out because it's not enough to make a meaningful impact, but the impact that you get from what you learn about your code greatly overpowers it. Again, it's important though that it doesn't block all of your function calls and that it's running asynchronously in a different thread.
Got it. For platforms like Dynatrace, that can instrument and do so much more as self-service, is OTel planning to add code analysis links to relevant code? Yes.
So I have seen, I think this would be like plugging one of my coworkers' blog posts recently talked about adding tags to your code where you can add in, like I know this is something that he's added for, this was slow in the answer service and has a link to in this file, line 92, answer service is slow here. So it is possible to do that. I don't know how automated any of that is right now, but that is something that people have been working on as, if nothing else, examples or ideas that are there. And I think that's specifically what we want to look at is, I think it's a blog post like adding tags to your code by Martin Thwaites or martin.net. I would recommend checking that out.
Include it in the follow-up, Jamie, if you send it over as well.
Sure.
The next question is, can tracing overhead be switched off, automatically switched on upon some triggers met?
I think the question was if you wanted to turn it off or turn it on easily, can you do that? And so the answer is yes, there are different ways of doing it depending on the language or how you've instrumented it. So for example, there's going to be some environment variables that should be included in the specification as well for something like set OTel exporter protocol to none, which says instead of defaulting to this OTLP format, turn it off. There are also, generally every language has a no-op tracer provider, which means that it doesn't really do anything. You've just added it to your code. So that's probably a little bit more manual or hands-on if it's after you've already instrumented it. But generally, that's going to be the way to do it, is to set the protocol to none or set the exporter to none. There's some environment variables available for that if you don't want to actually get your hands in the code. And then that should be available and a little bit different for each language, which that should be in the docs and or in the GitHub repos.
Thank you. Great presentation, Jamie. 2 questions. Does OpenTelemetry support other telemetries like metric and logs?
Yes. Yes. So there is a page on the OpenTelemetry docs website that goes into a little more detail about the status of each of these. So we have tracing, metrics, and logs. Obviously, today I mostly just focused on tracing, but tracing is the most stable. It's been around the longest. Metrics are now becoming more stable for each SDK. It differs a little bit, but metrics are a signal is what it's called now for each language, and logs as well. So logs are a little bit newer. They're going to be different availability depending on the language. I believe .NET and Python might have the most support right now, but that continues to get worked on. And that's another thing that the collector can be used for is, again, I showed exporting my traces, but I could also be taking in my metrics and my logs and exporting them to the same place, to a different place. Those are options for exporting as well. So again, the language, it might depend on how stable it is, but that is something that they're continuing to work on over time.
And the second question, for tracing, you showed that we should add propagation handler to our methods. I remember some services like Sentry doesn't need to specifically add any handler for performance monitoring. Are there any differences?
Yeah, so I would say there's something being worked on, at least for Go specifically, that we've been working on this sort of launcher or initialization layer that helps set some of those defaults for you. Some of the languages do have it pretty easy to set defaults, like the W3C trace context propagation. So some languages are going to be, I think, more verbose than others is how I would describe it. Depending on, like, if I use the Node SDK, there's maybe a few lines of code that I have to add, and I don't have to necessarily set that text map propagator. With Go, by default, you have to be a lot more explicit about that propagation that you want to set, and setting your context and passing your context into your different functions. So I would say that Go specifically is probably the most verbose as it comes to that, but depending on the language, they might have easier either defaults or maybe different ways of enabling or disabling different propagation formats. They also have, for example, if you're coming from open tracing or you're coming from maybe an older format, there are propagation options for using those instead, or if you wanted to switch over to a B3 format, for example, to work with Zipkin.
Thank you. The next question, how does this work with our unit tests and mocking?
It can work as closely to it or as different as you want it to. So we've had, and I'd actually like to try and find that blog post as well. I think that someone had put together that they had actually traced through their testing as well. I don't think this is specifically your question, but someone had instrumented their test suite so that they could see how long individual tests were taking, which was big for developer experience of those complaining that some of the tests maybe were taking too long. They can more easily see which ones were taking long and where they were slower in their functions. But this might be something that sits separate from that. One of the things that we do at Honeycomb with some of our distros, our SDKs, is that we have our unit tests, and then we have smoke tests where we actually spin up an app, spin up a collector, and then we make assertions against the output of that collector of our tracing data. So we want to check that it did indeed have this attribute, or it did indeed have this metric. So that's something I think the Java SDK has that as well, if that's something you want to look at. The Java GitHub repo also use smoke tests in that way to see that the tracing is happening the way they expect it to.
Thank you. For a language like Java, Python, there is any reason for manual instrumentation?
Yes. So the automatic instrumentation tends to be the nice, easy button, the on button, the just get started and let's go with it. But there are two things that you might find. One might be that it's noisier than you want. Maybe you're not getting as much data as you want out of it. Or two, it might not go as deep as you want it to. So one of the problems with my example is I didn't actually show a really complex computation That's where manual instrumentation would come through, is if it's already automatically tracing your HTTP requests, it's tracing your database calls, it's tracing all these different things. It still might not go deep enough into specific functions or methods or things like that that you might want to add. So for a lot of people, they might get started with automatic instrumentation just to see, what does this look like? Am I getting data that's valuable to me? And then they might see there's a gap here. Again, like when I showed the one in between service, and I apologize, I think I went a little bit fast, but we could see that in this 2-second call, we saw that 1 second was very specifically for this calculating of answer, but there was still a second that I couldn't dive into deeper. So usually that's what you'll find is when there is something that's a little bit slower and you're looking at your trace, you'll see a little spot that you want more detail in. That's where you add your manual instrumentation of, there's a gap here, I need to know more about what's happening there.
Thank you. What Sean is asking, what is no observability engineering flag in the resources slide?
Oh, shoot. I should probably add that in there. Yeah, we have an observability engineering book that I should probably put in there. It is a great book. It's an excellent resource. I was trying to stick specifically with some of the OpenTelemetry specific resources, but absolutely check it out, and don't want to go too far. No, a plug for that.
Okay, now forgive me my non-technical background, but I'll try to read this question. How good are the SDK slips for tracing message bus such as MQTT and RabbitMQ?
I don't have a lot of specific knowledge on that, but it would be something to check out on the OpenTelemetry website, where there's also a registry, which I think I have linked in the slide, where it has a registry of all OpenTelemetry compatible SDKs and libraries and things like that. So usually it will have a status on there of stable, experimental, alpha, things like that. And again, since it's open source and it's a community, you'll see open issues or PRs or things like that to try and see where the gaps may be and where things maybe need to improve over time. I just don't have a lot of specific experience with that.
Thank you. What about tracing around Redis, Kafka, SQS in general?
Yeah, so there's a lot. There's a few things there to cover. So there's like Redis instrumentation that you can add into your code. So if you actually make a call out to a Redis store, then you can have that automatically traced and let you know how long that takes. Similar things for Kafka, different languages. What you'll see is instrumentation libraries for those. And that will then have the instructions on how to trace those different services. So specifically what you'll be looking for is the word instrumentation or instrumentation libraries. And those will usually be linked from the GitHub repos or the doc site. And you can understand, and you can learn a little bit more about how to set those up for your particular use case.
Thank you, Jamie. They just don't want let you go. What are observability for microservices? How it will be displayed in UI?
So what I was going through in that example was a microservice. So I had a standalone gateway service, question service, answer service. And if I was able to see them in a UI, in a trace, because of the propagation that I spoke of. So in that case, I had to specify the trace context propagation, but those were microservices. And so a really great example, if you want to see a bigger one, instead of that small service that I had or the small app that I had, what you'll see linked in the resources is OpenTelemetry demo, which is a GitHub repo that has, it's a microservices architecture. I think it's a clone of maybe Google's microservices demo, and it's fully instrumented with OpenTelemetry, and you'll get to see different services, again, an e-commerce application. So like checkout, payment, product, things like that in all different languages, Go and Python and Java. So that's a really great example of a really big microservices architecture. But what I showed there was actually just a mini microservices architecture there as well.
And the last question we have right here, guys, if you want to ask more, we still have a few minutes. Are there hooks where a release DevOps cycle can add info to the overall collected instrumentation, like a new build or release that rolled out to track regressions?
Yeah, so there's a few options for that. One of the things that we have from Honeycomb is called build events and a build events orb that can be used with like Circle CI or Jenkins or Travis CI or things like that. And what people will do with that is they'll set it up to run through their DevOps pipeline to be able to see the different steps that take place, and they can then see if a step fails or something doesn't go right there. There are other options as well that aren't just under our umbrella. Like there's we might have taken on this one, we might have worked with the developer for a GitHub Actions build events. But the idea is to keep an eye out for like build events observability or build events instrumentation that does exactly that. You hook into your build pipeline and see the different steps of running each command and seeing whether things go, whether they succeed, whether they fail, or how long they take in each of those steps.
And one last question. What about instrumentation for async calls? For example, API that involves other call in our outbox pattern.
Yeah. So there's instrumentation for these asynchronous calls, and what will depend a little bit is on how much automatic instrumentation is there. One of the big things that happens with asynchronous code is that it can sometimes lose the context of its parent. So it doesn't, for lack of a better way of phrasing it, it doesn't know where it came from and it loses that piece. Generally, there are some wrappers that exist where you would wrap your function or your call out to another service. But that will depend on each of the languages that you go to. Like, for example, Python has instrumentation for some async requests, but there's an OpenPR for async gRPC AIO support. So the instrumentation is there for a lot of different scenarios, and it's continued to be worked on over time. So I would say check out the specific language that you're using, the specific instrumentation that you're using, and see what's available for that particular language.
And are there guidelines to developing instrumented code, things like good practices, patterns, etc.?
I would say the big thing really is again, starting small where you can. So you may have, when you first get started, you may have this desire to say, instrument all of the things. I want all of the functions, all of the calls, all of the services, all the everything. And what can happen there is you might end up with a lot more than you really realize that you needed. And you might get overwhelmed, or it might take a long time and it might be hard to go through. So when you can start smaller or start with the areas that have the biggest impact. So if you have, like you'll see the links in there, if you want to start with automatic instrumentation because it's an easy on, easy off sort of button, just to start seeing what you get, that's a great idea. If you realize that that's not quite what you're going for, maybe that's too much, then you start going into instrumenting your individual places where things are slower. The benefit of starting with either automatic instrumentation or instrumenting your HTTP calls or your database calls is some of that instrumentation is going to open your eyes to where things are slower in your service. And that gives you a better idea of what to dive into. But there's also the general idea is you want to see start to finish. And as I mentioned in the presentation, observability driven development, it sounds maybe a little cliche, but when you get used to doing it as you're writing your code, it's just like writing your tests alongside your code. You have more confidence in what you're working on. You have a better feel for how it's affecting your overall process. If you just run a trace on a service and you see it takes, 1 second. And then you add a feature and it takes 2 seconds. Well, that's huge, right? That's a huge difference. And by checking that out as you're working on the feature, everything's fresh in your mind, your hands are in the code, and you can see that there's a big problem there instead of waiting for it to get to production. So I would say that adding that instrumentation as you're developing that feature is going to save you heartache and headache later on. And then if you see that you need more later, you can still add it, but you've already gotten the foundation for it.
And thank you. One more question from Dayon. Where are the telemetry data stored and how large can it get? Are there any constraints which limit the data amount collected over time?
Yes. So there's a few pieces to keep in mind with this. So you have, if you start at the end and work backwards. So let's say you start at your telemetry backend. If it's Lightstep or Honeycomb or Datadog or whoever, they might literally have a retention period of how long stuff stays there. So if you're talking about that, that will depend on the vendor or the backend that you're working with. And if it's local, it might get cleared once you're done working with it. If we then move back a step, let's say we're working with a collector. There are configuration options within the collector that let you choose how much of that telemetry data gets built up before it gets sent on with that batch processor. There are different configuration options that you can set to say, send after 5 seconds, or wait until I've gotten 10,000 items in here and then send it off. And so you can kind of tweak those settings depending on maybe what you're seeing. You'll usually see some kind of an error like context deadline exceeded or event is too large or something like that from the telemetry backend back through the collector that will tell you that you need to make that smaller. And then we go all the way back to the app. A lot of times there will be options there of how much is collected before it gets sent off. But that's the idea of that batch span processor is it's going to hold on to it, and different libraries might give you the option for a timeout or for automatically sending that along. But generally speaking, it's not staying there for a really long time. You can export it, say, to a file. So for example, with the collector, you can export it to a file and save that if for some reason you wanted to have that, or you can, save things elsewhere. Generally, you hopefully don't need that in that way. Once you have it into your vendor backend, it's immediately useful for you and you can work with it. But generally it's not, there's going to be some kind of a timeout of how long it's going to hang out in a batch before it gets sent off.
And we have no questions. Oh my God. Jamie just answered like 15 questions. I'll put the link to our platform engineering Slack channel. Jamie will hang out there today and tomorrow. Please feel free to ask questions. I know Gila also posted the recording to the webinar over there. You can just like ask the question below the post. But other than that, thank you so much, Jamie. It was super, super incredible. You've seen it itself, like many compliments, a lot of questions. I don't remember when we had so many questions the last time. We'll send over the webinar replay, the slides, and a couple of useful resources that Jamie mentioned already during this recording tomorrow. Other than that, hope everyone has a great week and see you at KubeCon, whoever is going. Bye. Bye. Thank you, Jamie.